Let's look at probabilities and let's look at a single event. So, the first thing to understand is probabilities run from never to always. And in the middle, obviously, there's a half chance. And the probability of never is 0. And the probability of always is 1. Probabilities less than 0 or greater than 1 do not exist. And in the middle, it's a half. So let's have a think about what we can get. Probably not. Probably not. Well, it's not never, but it's down here. What about likely? Well, again, it's not always, it's not 100% certain, but it's likely, so it's up here. And 50-50, you guessed it, it's a half chance. No way. Might be an exaggeration, but that's never. Probably. Again, it's up here. It's not always, but it's on this side. Definitely. Well, that's always. Unlikely. Well, that's with probably not. A probability question will appear in your exam. Right, it is likely, it is probable, but it's not certain. Even if history suggests probability is the most popular question. Roll a 7 with an ordinary dice. 0 chance. It's never going to happen. It will snow in the UK in July. This is an actual question. Probably not, but not absolutely impossible. You get a volcano, things get cold, it can snow. So there you are, so a little spread. Calculating the probability. The probability of an event is the number of ways of achieving the event over the total number of possible outcomes. Oh, it's a bit of a long way of saying it, isn't it? Let's just say ways to win over total possibilities. For example, tossing a coin. There are 2 outcomes from a coin toss. A coin toss. Heads and tails. So for a fur coin to result in heads, there's only one way of doing it, but there are 2 possible outcomes. So the probability is 1 over 2 or a half, you know that. So the probability of an event is ways to win over total possibilities. Probability of a fur dice rolling a 6. How many ways can you roll a 6? Well, 1 over the total number of possible outcomes. There's one way of rolling a 6. It's 1 over 6. Thank you very much. The probability of a fur dice being even, it's a bit more complicated. You can throw a 2, a 4 or a 6. So that's 2, 4 or 6, 3 ways, but there's 6 possible outcomes. So that's 3 over 6 or a half. Let's have a look at an example. A bag contains 12 balls. 3 of the balls are red, 9 are blue. That's all the balls. 1 ball is taken at random from the bag. What is the probability this ball is red? Well, each drawing of a ball, each individual ball, is a possible outcome. And there are, to state the formula, there are 3 ways of pulling out a red, but there are 3 plus 9 different possible outcomes, which is 12. 3 over 12 equals a quarter. Divide top and bottom by 3. Common mistakes. Under stress, people say silly things in exams, and this is one. What's the probability of an event? It's ways to win over total possibilities. Here we've got 4 blue, 2 green, and 5 red balls in a box. 1 ball is taken from random from the box. What's the probability this ball is green? Well, probability of green, you can get a green ball, or you could get a blue, green, or red ball. So the probability is a third. Well, no. No, these are ways to win by bowling a green ball, and these are the total possibilities. But importantly, each ball is a separate possible outcome. And it ignores this information. If we look at the bag of balls, we've got 2 green, we've got 4 blue, we've got 5 red. So there are 2 plus 4, 11 different possibilities. So the possibility of a green is 2 of those balls divided by the total number of balls, 11. There's 11 possible outcomes. 2 of those are ways to win. So it's a subtle but extremely important difference. Probabilities sum to 1. We've seen that the probabilities sum to 1 before, but let's go over it again and recall that probabilities of, if you add the probabilities of every single outcome, they will add up to 1. Well, we can prove that. The sum of probabilities is 1. Recall that the probability of a head is a half. And we can also find that the probability of rolling a tail is a half. So the probability of head and the probability of tails add up to 1. This is also true of a dice. The probability of throwing a 1 or a 2 or a 3 or a 4 or a 5 or a 6, if you add those up, each one of those is a sixth. One way of throwing a 1, 6 possible outcomes. Add them all up, that equals 1. The estimated number of outcomes, this is a funny little one. The estimated number of times an event occurs is equal to the probability of the event in a single roll or a go or a try times the number of turns. So it's easy to see this from an example. The expected number of heads from 100 tosses is the probability of throwing a head in a single turn, and the number of tosses is a half times 100 is 50. You will not be surprised to know the probability of the expected number of tails from 100 tosses is 52. The expected number of sixes from 120 dice rolls, well, the probability of rolling a 6 times the number of rolls, probability of rolling a 6 is a sixth times 120 equals 20. Here's an example. This is a far-sided spinner, which means it can equally land on any of these edges. The spinner is spun 200 times. Estimate the number of times the spinner lands on red. Now, these questions sometimes hold a trick, and this is red appears twice. So it isn't just one side, it's 2 sides. It can arrive on any of those 5 sides, and 2 give us a red. So probability of it lands on reds is the number of reds over the number of possible outcomes is 2 over 5. The expected number of reds from 200 spins, therefore, is probability of a red on a single spin times the number of spins. 2 over 5 divided by 200 times 200, 80. There's a sort of logical check here that if you're spinning it 200 times and you've got 5 sides, you'd expect every side to come up 40 times. That's 200 divided by 5. But 2 of the sides are red, so you'd expect red to come up 80 times. Oh, good. How do you remember all these rules? How do you make sense of them all? Let's think about the main operators and see if we can associate a rule to each operator. The plus, well, that's the total equals 1. The total of all the probabilities of all outcomes is 1. Probability of heads plus the probability of tails is 1. The division is the formula for a probability, or the equation. The probability of an event is how many ways to win divided by the total possibilities. I use ways to win because it's more easy to remember than outcomes and trials and things. How many ways to get what you want divided by the number of possibilities. Times multiplication, that's the estimated number of an outcome. The probability of an outcome on a single turn times the number of turns gives us the estimated number of times that outcome will occur. Bit of a stretch for the minus sign. I've used the minus sign to represent the spectrum, the scale, which runs from 0 through to 1. 0, never, no chance. 1, every time, and half, well, chance of tossing a head on a single spin of a coin. I hope that helps. Cheerio.